Hi everybody. Lesson 11.1, we're going to look at similar polygons and what exactly does that mean. Yesterday we did an algebra review with proportional reasoning, just working with setting up and solving proportions, and you'll see that will be a main feature of this, really this whole unit as well. So this is the actual start of the last unit, lesson 11.1. Now, our definition, and we would have done a little investigation with this, but our just plain old definition of similar polygons says, and let's just write this out, polygons are similar. I'm going to use this phrase. Do you remember this if and only if? You can abbreviate it IFF. If and only if. There's two parts here. The corresponding angles are congruent, and both of these things have to be true. The corresponding sides are proportional. Okay, so corresponding angles are congruent and the corresponding sides are proportional. Now, think about the word proportion. We've got two ratios equal to each other. So we're going to be able to test out if the sides are proportional or not by setting up these different ratios. Okay, so both parts of that are needed. The if and only if part is there because, remember, we could just kind of flip that around. Let's say you had two polygons and you could tell by looking at it like, oh, all the angles are congruent. Great. All the sides, yes, they have the same ratio. Great. Now we could determine that they're similar, and we'll see a problem where we need to do that. Okay, so here's just an example of what similar polygons look like. You can copy this down if you need to, or just reference this video. I think of similar figures as you do this all the time. Think about your cell phone. How many times do you pinch and zoom? Whether you're making something bigger or smaller, you're enlarging or you're shrinking. You're keeping everything proportional, and we tend to have a pretty good intuitive sense of what that means, but we'll get down to the nitty-gritty and what that actually looks like mathematically as well. Okay, so you can see these two polygons here. Let me name the first one just ABCD. ABCD. Between these two, check out the angle. So angle A congruent to angle W, angle B congruent to angle X, etc. C and Y, D and Z. So we would say, well, I'm missing half the piece here. Let me backtrack. So the angles are all congruent, we can tell, right? So the corresponding angles are congruent. Put a big check mark by that one. Now, to tell if the corresponding sides are proportional, I'm just going to abbreviate that for a second here. What we really should be testing every single time is the all possible ratios. Okay, so for all of the pairs of sides. So let me start here with side AB compared to WX. So if I look at this ratio, 11 to 110, we want to know, does that equal this ratio, 15 to 150? And we have to check all of them. So does that equal this, 4 to 40? Matching up all of my corresponding sides. They're not congruent like we're used to with corresponding sides. And again, does that now, what's our last one here, 8 to 80? This one I think is fairly easy to see. You can just see, oh look, times 10, right? Times 10, times 10, times 10. All of these, if I reduce them, do equal 1/10. All right, this polygon is 10 times bigger than this one, or if you want to flip that around, this small one, ABCD, is 10 times smaller, right? It's 1/10 of the size. But what's important here is that all of these are exactly the same. If you had even one ratio that was not equal, we would not say that these polygons are similar. So we're going to put a check mark here. Yes, the corresponding sides are proportional. So now we can say that these polygons are similar. So look how I named this here, A, B, C, D. We have a new symbol, just this one single little squiggle for similar. And the order of the letters matters here as well. Okay, A is congruent to W. So if A is my first letter, W has to be my first letter. Okay, B and X, second and second letter, and then we work our way around. W, X, Y, Z. Okay, so the order matters. That's going to be important when you're trying to find missing sides or angles. you'll need to match up those letters. Okay, so let me just make a note here so it's clear in your notes. This symbol, one big squiggle, means similar. If you need the little reminder, I know it actually has been a little while since we've seen this. Remember, that one is congruent. Here's the difference. In this one, yes, corresponding angles are still congruent, but corresponding sides are congruent. Now we're talking about proportional sides. Okay, so here's a pretty straightforward example that we could see. They tell us right off the bat that these two polygons are similar to each other. Find x and y. So x is this side, y is this angle. I'm actually going to do y first because all I need to figure out is which angle does it sort of match up with, what's its corresponding angle, and it's the same. There's no calculation needed here. If you're not 100% sure, like let's say that maybe one of these was rotated, or some of the sides look so similar or angles look so similar you can't tell what matches up. Remember, you can always go up to your similarity statement up here. So look where letter I is, second position. That's matching up with M, second position. Okay, so of course, yes, we can tell that's 83, but some of them are a little more challenging than that. So y is 83 degrees, nothing more to do with that one. Now, when you get to the sides, this is where these proportions come into play. I want you to try it on your own first, set up a proportion you would use to find x, and then come back and check mine. Okay, so let me give you one option. We could do something like x over 21. So I'm setting up these two corresponding sides, x over 21. Now I've got the bigger polygon on the top of my fraction, so I just need to be consistent here. That equals 24 over 18. So it's okay to sort of jump across the polygons as long as you're consistent in how you kind of set up your numerator and denominator. So that one's fine. You didn't have to have that. Of course, you could take reciprocals. You know, you could have put the x on the bottom. I can also go within this one polygon. So I could also say x over 24, okay, so sort of this bigger side to this smaller side, is equal to 21 to 18. Again, being consistent here. So bigger side, oops, to smaller side. What I don't want to do is sort of get that all jumbled around. This would be a bad one, right? We talked the other day about setting up bad ratios. So if I do x over 24, and I try to set up then 18 over 21, you see the issue there? Okay, so this one is bad. Do not set that up. And then in either case, when you actually go to solve, we'll again cross multiply here. 18x, I'm going to use this one, equals, oops, let me get my calculator out here, 21 times 24, 504, and then divide that by 18. So x is 28. Okay, so that's how we work with that one. Again, the angles, just match them up. Make sure you're doing it with the correct one, and pay attention to that similarity statement because we will certainly see some where it's not nice and neat. This picture's kind of all, you know, positioned the same way. If this is rotated or the angles are fairly close to each other, you really want to pay attention to the letters up here.